Ladies and gentlemen, welcome to the last unit. These are definitely going to challenge you, so it's really important you use the textbook if needed. Notice that at the top of your notes, it says where you can find it, and that you let yourself try all the homework, okay? I can't even tell you how important that is. So before we get into the Pythagorean identities, think about what we know cotangent to be. Okay, cotangent can also be written as 1 over tangent because it's the reciprocal. Yeah, it can also be written as cosine of theta over sine of theta. These are all considered basic trig identities. Secant we know to be 1 over cosine of theta, right? The reciprocal. Cosecant 1 over sine theta. Tangent 1 over cotangent theta, which is a little weird, I understand, but it still can be written like that, right? Or sine theta over cosine theta. So those are considered the basic trig identities. You've been using them, didn't know they were identities. No, you're welcome. And then think about, before we continue on from there, think about how I would simplify. If I have 1 plus 3 over x, what do I have to do? Yeah, we have to get common denominators, right? So I'm going to multiply this by x over x. And we're going to end up with x over x plus 3 over x. And then you're just going to get x plus 3 over x. So if I'm adding a number to a fraction or two fractions together, you need to get the common denominators. Okay, well, what if I have sine squared theta plus cosine squared theta? We're stuck, right? Well, think about, maybe we're not stuck. Maybe I'm on a Cartesian coordinate plane and I'm a triangle. Hi, I'm a triangle. And I'm a triangle in the first quadrant, right? Right triangle, reference angle. And we know that this point, if I was on a circle, would be written as cosine of theta sine theta. Okay, these are all true statements. And we also know that this is considered cosine of theta to get here, and then to go up is sine of theta. And then if we're on the unit circle, this is 1, right? So if I am on the unit circle, and I know that I am dealing with a right triangle, can I not then say that sine squared theta plus cosine squared theta is equal to 1? You absolutely can. Ladies and gentlemen, I would like to introduce you to the first Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. That is the first and really most important because the other three come from this. How? Well, think of it this way. If I have sine squared theta plus cosine squared theta is equal to 1, it's not really where I want to do it at. Let's do it down here. Sine squared theta, plus cosine squared theta is equal to 1. And I divide everything by sine squared theta. Why? Why not? I'm just playing around, moving some stuff mathematically. I am allowed, right? So if I do that, this becomes 1. This becomes cotangent squared theta, and this becomes cosecant squared theta. So therein we have your second Pythagorean identity. So 1 plus cotangent squared theta is equal to cosecant squared theta. It came from the original, but it's dealing with two different trig functions. Kind of cool. All right. Well, what if we have sine squared theta plus cosine squared theta is equal to 1, the original Pythagorean identity, and you divide everything by cosine squared theta? Why not? We're just moving some stuff, right? In doing that, you get tangent squared theta plus 1 is equal to secant squared theta, your second Pythagorean identity. So why I say the first one is so important is because it is. You can generate the other three by dividing by sine straight through. And the reason I say that I can do that mathematically is because if I do it to one piece of my equation, and then I don't do it to the other, that's not allowed. But I divided every single piece, so my equation stayed equal. Yeah, it stayed the same. Oh, I feel a sneeze. Sorry. Okay. Something that you do need to be aware of with these three Pythagoreans is you need to memorize them, obviously. If you know the first, you can generate the other two. Okay, so if you are struggling with how to memorize, always memorize sine squared plus cosine squared equals 1, and the other two follow. But the last thing is that sine squared theta plus cosine squared theta equals 1 can also be written as sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta. Every Pythagorean identity, so each of the three, has various versions simply by subtracting some of the pieces. And the reason that this is important is because as we get into verifying identities or proving one side of an equation looks like the other, you may need to use some of these variations. Okay, so we could also say that 1 is equal to cosecant squared theta minus cotangent squared theta. We could say that cotangent squared theta is equal to cosecant squared theta minus 1. These are the different variations. You could say tangent squared theta is equal to secant squared theta minus 1, or 1 is equal to secant squared theta minus tangent squared theta. Okay, what I want you to focus on is memorizing the top three. Okay, again, if you have trouble memorizing, then definitely just memorize sine squared theta plus cosine squared theta equals 1. You can generate the other two from there, and then just by subtracting pieces can you generate the additional 6. Okay, why? Why do we need to know these? Because we're going to be asked to verify or show. So big thing with these is that you need to practice. If you start with one side of the equation and you hit a roadblock, okay, it's going to happen. Stop, go to the other side and start from scratch. Okay, it's going to take trial and error. You cannot work with both sides at the same time. Okay, so you might want to write that down. Manipulate one side only. It will be illegal and completely wrong. So if you work with both sides. So manipulate one side only. That is super, super important. So we're going to need to show that this trig identity is true. And you cannot state, oh, it's true because, Patterson said so. No, it's true because it's one of the identities. Not how that works, sorry. You need to work with one side to make it look like the other. So first thing I'm going to do is I'm going to start with the somewhat more complicated side, the side that has more to work with, which to me is the left side. I'm going to change cotangent squared. If I can change trig functions to be cosine and sine, oftentimes it will lend itself to whatever side you're going to. And please, please, please make sure you always look forward. Always know where you're trying to go. Okay, for this one, we're trying to get cosecant squared. That is the reciprocal of sine. So maybe if I can get these to be the reciprocal of sine in some way, we'll be okay. Well, just like the adding fractions up here, I need to get common denominators. So I'm going to make the 1 be sine squared of theta over sine squared of theta. Why? Because I see that the second fraction has sine squared of theta in the denominator. Notice I'm working in a horizontal pattern. Vertical. What? I'm going vertically. Do not go all over the place. I will tell you right now, if on your test you are all over the place and I cannot follow, I will not grade it. Okay, you have to be organized in your work. It has to follow a specific pattern. If you need to work horizontally, use arrows so that someone can follow. Okay, but vertical is the preferred direction. Here we have common denominators, so I'm going to say sine squared plus cosine squared theta over sine squared theta. And then, my numerator is a Pythagorean identity. I'm now allowed to use that identity because I'm not trying to prove that identity, okay? If you're being asked to show, verify, prove an identity, you cannot just say it's an identity. The other ones you can use in its place. So then I have 1 over sine squared theta. I cannot then say I'm done. I must have the final sentence showing that I understand that reciprocal is the cosecant, and then I am done. I didn't skip any steps. You cannot skip any steps. It needs to be 100% thorough and easy to follow. All right. Okay, so let's do some verification. Take a look at A. I have sine theta times cotangent theta is equal to cosine of theta. Well, the left-hand side has a lot more for me to work on. I can't change sine. Well, I could change it to its reciprocal, but that just seems silly. And then I could change cotangent to be cosine of theta over sine theta, because that is one of the basic trig identities. Ooh, I know this is over 1, so these will cancel out, and right away I am done. Cosine of theta equals cosine of theta. Done. Nice. It's always nice when they work out small and simple. Okay, take a look at B. 1 minus cosine squared of theta. I feel like that should be one of the Pythagoreans, but I know it's sine squared plus cosine squared. So if I go back up to that box, aha, it is one of the additional ones. So 1 minus cosine squared theta can change to sine squared theta. And again, the reason I'm starting with the left side is because there's more to work with. If I have 2 sines over 1 sine, one of them can reduce, so then I get sine of theta is equal to sine of theta. Nice. Okay. You want to try to use the basic trig functions, or identities, pardon me, as well as the Pythagoreans. If we look at C, we have sine squared theta times secant theta plus cosine of theta is equal to secant of theta. Okay. I'm definitely working with the left side. There's more to work with. Pardon me. And keep in mind where you're going. I'm trying to get secant of theta, which is 1 over cosine. Okay, so I'm going to leave sine squared theta for now. But I am going to change secant to be 1 over cosine theta so that all I'm dealing with is sine and cosine. I don't know if this is going to work. I'm just trying something out. If it doesn't work, I'm just going to erase it and start over. Okay, not a big deal. I'm just trying something. Don't be afraid to try. That means that I get sine squared theta over cosine theta plus cosine theta. I am going to need to get common denominators here. So this becomes sine squared theta over cosine theta plus cosine squared theta over cosine theta. Here I'm not showing what I'm multiplying top and bottom by, but from one step to the other, it's obvious to see that now this has become cosine squared theta over cosine theta. Common denominators, so I have sine squared theta plus cosine squared theta all over cosine theta. That is a Pythagorean identity. So sine squared theta plus cosine squared theta is 1 over cosine theta. I am not done. Please do not leave it like this. You must rewrite it as secant of theta because that's where you're trying to go. And then we're done. Nice. Okay, so different ways to show, different ways to verify. You're also going to be asked to simplify, and you might need to use your Pythagorean identities or the basic trig identities. Okay, when you're asked to simplify, your goal is to get one trig function if possible, and if it's a reciprocal, don't leave it in fraction form. Okay, so looking at this, 1 plus cotangent squared. Well, I'm going to go back up to my identities. 1 plus cotangent squared theta is cosecant squared theta. So I'm going to go ahead and change this to be cosecant squared theta over cotangent squared theta. Now, please know, just because I'm doing it this way doesn't mean it's the only way to verify. It's the only way to simplify any of that, okay? Not at all. Many different ways. If you're curious if your way is mathematically correct or allowed, let me know. I'll check it out. I don't mind. Okay. So, gosh, I'm stuck. Well, I know that this is the cosecant squared theta divided by cotangent squared theta. And I also know that cosecant is 1 over sine squared theta. And cotangent is cosine squared theta over sine squared theta. All right. So then if I'm dividing fractions, 1 over sine squared theta stays the same. And I multiply by the reciprocal. This is looking nice. Okay. I'm running out of room vertically, so I'm going to draw an arrow. Well, the sine squareds cancel out. So I'm left with 1 over cosine squared theta. I cannot leave it like this. It is not simplified because it's not one trig function. It's a fraction. So I'm going to change it to secant squared theta, and I am done. Now, for simplifying, it's possible we take a different route, okay? But we should all end up at the same simplified answer. Keep that in mind, please. All right, I know these say you try. I'm going to do most of them with you because I'm not with you, and I want you guys to get the practice, see the different forms. It says to simplify. If there's an equal sign, then that means you're asked to verify. I know sometimes it can get a little bit tricky with the directions, okay? So please make sure you pay attention to which is which. I'm going to multiply by the conjugate because right now there's nothing I can change. There's nothing I can manipulate as far as, my basic trig identities. Don't think you can use your Pythagoreans either because they are not squared. This is not 1 minus cosine squared of x. It's 1 minus cosine of x. But I could get common denominators. So that's where I'm going to go. I'm going to multiply this side by 1 plus cosine of x over 1 plus cosine of x. And I'm going to multiply this by 1 minus cosine of x, 1 minus cosine of x. Why? To get common denominators. Okay, again, you can't use your Pythagorean identities because these are not squared trig functions. You might want to go back and make a little note. Must be squared because you'll notice they are all squared trig functions. Muy importante, very important. Okay, so in the numerator, I get 1 minus cosine of x. Now, what's super nice is that I multiplied by the conjugate, so I end up with 1 minus cosine squared of x. Conjugate is the same binomial, but opposite operation, okay? And then I have plus 1 plus cosine of x all over 1 minus cosine squared of x. Okay, now same denominator, so we can combine. We get 2, the cosines cancel, all over 1 minus cosine squared of x. 1 minus cosine squared of x is an alternate form or an alternate form of the Pythagorean. So this becomes 2 over sine squared of x, but we are not done, ladies and gentlemen, because this is 2 times 1 over sine squared of x. So this becomes 2 cosecant squared of x. Now we are done. Do not leave fractions, okay? Change them into their reciprocals. Those are some of the basic trig identities. Sweet. So sometimes you'll have to multiply by each other's denominator to get common denominators, and that's okay, as long as you have the same numerator and denominator being multiplied. All right, for 2. Wow, there's a lot going on. There isn't an equal sign, so I'm going to just try to simplify and manipulate. I'm going to leave the cosine cubed beta, that's beta, over sine beta, and then I'm going to change tangent. Tangent is sine over cosine. I'm going to change it so that hopefully all my trig functions are the same and we can see if something will happen here. And then plus sine cubed beta over cosine beta times cotangent. Cotangent is cosine beta over sine beta. Well, this will work out nice. Okay, so sines will cancel, cosines will reduce, so we get cosine squared beta. And then cosines cancel, sines, oh, hey, plus sine squared beta. Cosine squared plus sine squared is 1, Pythagorean identity. Remember with the commutative property of addition, 2 plus 4 is 6, 4 plus 2 is 6. Okay, so it doesn't matter what comes first. They're being added. You can do it in different directions, we'll say. What's the word for that? Yeah, you know what I'm talking about. If not, let me know. Okay. Well, now look at 3. There's an equal sign, so that means that we definitely are trying to make one side look like the other. And I'm going to work with the left side because there's more to work with. And I'm going to multiply by the conjugate. So and the only reason is because right now I can't use my Pythagorean identity. Okay, that's off the table because it's not squared in my denominator. It's not 1 minus cosine squared x. But if I multiply by the conjugate, I could do that and see what happens, okay? So I'm going to say sine squared x times 1 plus cosine x all over 1 minus cosine squared x. Right away, my denominator, well, the numerator stays the same. That's why I'm rewriting it. Okay, denominator is a different format of the Pythagorean, so we get sine squared x. Boom, boom. Sine squareds cancel, and I'm left with 1 plus cosine of x is equal to 1 plus cosine of x. You definitely need that last statement. Nice. Very nice. You could have maybe possibly seen that this could have been changed to 1 minus cosine squared x and then factored that out. That would have been fine also. You would have gotten the exact same answer, okay? Different ways to do it. Same result. All right, take a look at number 4. Again, the reason I'm doing these with you is because they all have some sort of a different approach. So it's good for us to practice, yeah? Tangent theta times sine theta is equal to 1 minus cosine squared theta over cosine of theta. I'm going to work with the right for a change. It really wouldn't matter which one you guys did, left or right in here, okay? But I know that in my numerator, 1 minus cosine squared theta is sine squared theta over cosine theta. Okay, now you might be stuck, but remember where you're going. You need one sine and sine over cosine. So all I'm going to do is pull out a sine theta and then multiply it by sine theta over cosine theta. Yeah, this is over 1, so you're totally allowed to do that. And then you're left with tan theta, sine theta, which is exactly what you were trying to get at. And you're done. Rad. Okay, number 5. Number 5 is the last one I'm going to do with you, and then number 6 you guys can try, because number 6 is a little bit similar to number 3. I'll stay green. Okay, am I still green? Yes. Just making sure. All right, 1 minus tangent to the 4th beta is equal to 2 secant squared beta minus secant to the 4th beta. Hey, this is fancy. All right, so what I'm going to do is I'm going to go up and see what I can work with. Okay, we know tangent squared theta plus 1 is equal to secant squared theta. Okay, and then you have your different variations. And so we can use any of those. It's kind of nice. Approach it how you feel best. Gosh, left or right, left or right. Let's work with the right. Okay, so then I know I'm going to put 2 secant squared beta is the same as tangent squared beta plus 1, okay, minus, oh man, secant to the 4th. Okay, so then that's going to be secant squared beta times secant squared beta. The reason I'm going to break it out like that is because, plus 2, the Pythagorean identities, yes, good, some of you I'm sure are saying it already, are squared. Okay, so then I distributed the 2 in case you missed that. So 2 tangent squared beta plus 2 minus, this becomes tangent to the 4th beta, I'm just foiling, plus 2 tangent squared beta plus 1. Okay, I'm going to distribute the negative. So we get 2 tangent squared beta plus 2 minus tangent to the 4th beta minus 2 tangent squared beta minus 1. These cancel, which is beautiful. And then we are left with 1, because 2 minus 1 minus tangent to the 4th beta. And that's what we needed. That worked out rad. I wasn't really sure when we first started. Something to keep in mind though, if you didn't want to do that, which it wasn't too bad, but if you didn't see that this had to be split, you could have foiled it or factored to 1 minus tangent squared beta times 1 plus tangent squared beta. This becomes secant squared beta, and you could have gone from there. Okay, if you guys would like to see how that was done, just email me, let me know, and I'll do it on a separate video, okay? All right, so what I want you guys to do now, pause this video and try this one on your own. I'm going to pause and work it out. Okay, I hope you paused. Anyway, I chose to break out cotangent squared into its Pythagorean identity different format and then factored that out. You might have chosen to multiply this by cosecant x minus 1 over cosecant x minus 1. That would work as well. All right, awesome. Enjoy the homework.